Hi again. Last time we had some unpacking, and today there will be no unpacking because I already prepared some unpacked TrickBot sample for you, and I will show you some of my tricks and that I used to deobfuscate strings and that are in this unpacked TrickBot sample. First of all, I will show you on which part of the TrickBot we will be analyzing today, because TrickBot always comes packed. After we unpack this custom layer, we have a main loader, and this main loader have 3 resources inside. All of them are some executables, and depending on what operating system we have, we can have only one of this main bot deployed. Either it's a 64-bit bot or 32-bit bot. And here I have this 32-bit bot unpacked from this sample of TrickBot. I will just show you very briefly how it looks. It have import table here, and it have 2 resources, and this is important because this main bot will always have 2 resources. One of them is going to be the configuration in encrypted form, and the other is going to be the elliptic curve key. But now we are not gonna go in details of it. Just remember that the part that we are analyzing now is this main bot 32-bit. So we can have a look at this bot first. We can have a look at the strings of this bot, so that you will know what exactly I'm gonna show you. So I'm deploying strings command on this bot, and we see it have imports. Maybe I would rather than this, I will dump them to a file so that they will be more easily browsable. So we can see that it has some strings inside. They look like base 64, but it is not a base 64 in a pure form. It is obfuscated by some custom algorithm, and to make things worse, though this algorithm is not the same in each and every bot, so they look similar but they are not exactly the same. So if we would like to statically unpack it, it's additional hassle because this algorithm have some small differences from version to version. Well, I tried to apply also some other more complex tools for deobfuscating strings, but you can see the result, it's not going so well. Yeah, so it's running. Let's see how long it will run. And in the meanwhile, I will show you how this sample looks in IDA. Open sub and strings. We can find here the same obfuscated strings. Let's see where are they referenced. And we can find that there is some big array of those strings. Yeah. And this array will be referenced by the coding function. So this is the function that takes as an argument an index of the string that is supposed to be undecoded. And what this function does is basically it calls the other function that is responsible for decrypting and the single string. So this is the offset of this function. And yeah, if we look at the API of this function, this one takes 2 arguments, and well, it's best to see it under some decompiler, but if we analyze it more further, we can also find that those arguments are both array of characters. First argument is an input array that contains this obfuscated string, and the second argument is the output array where the obfuscated string is stored. And as a result of this function, it will return the length of the decoded string. So this is how it works. And yeah, and now I will show you my tiny utility that I made with the help of my library libPeConv. And by this way, I deobfuscated all those strings. And let me show you first how it runs. So it takes 2 arguments, path to the malware and string to decode. That is optional, because if you don't give the string to decode, it will automatically fetch this full array of strings, as you saw, and it will decode all of them. And why do we need the path to the malware? And just because this is the way the decryptor works. Rather than re-implementing the function, rather than analyzing how it works, I just grabbed the API that I saw in IDA, and with the help of my library libPeConv, I loaded the original malware and I imported those decoding functions from the original malware. So I use the malware like a library to fetch those functions and use them and apply them, and I don't even need to go in details what this function does. So it can be just used very fast without any detailed analysis. I will show you first how it works, and then I will explain you how I made it. So this is my project. It's built, and it is exactly here. It is inside here. I will copy this project, and I have the bot here. So it has a default name, project template, and I will explain it after a while. It's just because I just grabbed a template from my GitHub and I built this tiny utility on the ready-made template that I made before. So that's why it doesn't have any specific name. So let's run it on this bot. Okay. Why it can't open the file? Okay, I applied on the wrong. I applied on the IDA database. So we see all those strings that were encrypted are not decrypted, and here we have indexes of those particular strings in an array. I will store them in the test1 file. We can see what we got before. Yeah, we didn't got much. And in here we have all the strings decrypted, so basically we can read TrickBot like if it was never obfuscated. Let me show you now how I did it. It's very simple, and the same technique you can apply on other malware. I apply it a lot, so I just wanted to share with you. First I load the malware with the help of libPeConv. Then I use just the API that I reconstructed by reverse engineering. So I know that this function takes 2 buffers. Yeah, I know what is the type of the function, and it is enough. The other function that takes indexes, and the output buffer is here, and I know also its offset. Yeah, you see, and this is the offset of the other function. Yeah, I noted it. And knowing the API, importing the malware, I can after that use those offsets. Also, I have the offset to the array, yeah, so I can directly read the array from the imported malware and decrypt this array by also the function that I imported from the malware. And this snippet I will also link to the video so you can take a closer look. And yeah, I calculate those are relative offsets, so I have to add them to the offset where the malware is physically loaded, and then I cast those functions to the particular type, that is the type of the function. Well, and now I can use it like any other local function to and make it decode anything I want. So if the string was supplied as an argument, I will use this particular string, and otherwise if nothing was supplied, then it will fetch this internal table to which I also gave the offset, and it will decode this full internal table. So now let's make an example of the string. If let's say we want to decrypt one particular string, let's say maybe this one. Okay, just copy it, and I will pass it as a parameter. Nope. Yes, it decoded this one. I'm not sure why it didn't decode this one. Maybe it's obfuscated by a different function, or maybe yeah, it decoded it. It was just, I think, cut it in between exactly. So this full string should be going from here okay, going from here, and this is the continuation. Yeah, so we got it, and this is how it looks. So you can find the links under the video, and in the second part I will show you how to apply the same small utility on a different TrickBot, because I will show you that this method can be very easily customized to another TrickBot. At least those TrickBots that I'm seeing nowadays they all use the same API to decode strings, although they have some tiny differences in the strings themselves, but the API is same, so only changing offsets and recompiling it is enough to just customize this tool for the other TrickBot. But obviously it can change in the future. But more than about those particular strings of TrickBot, I just wanted to show you the method because I use it on other samples also, and it can make work a lot faster. So thank you, see you next